Historically, there have always been two different routes for steelmaking. The first one uses blast furnaces and iron ore as raw material. The second one, which is the one that we have here in Sidenor, uses instead an electric arc furnace and mainly scrap as raw material. These two routes have coexisted for many years, but the current challenges towards decarbonization are changing the situation, as many blast furnace steelmakers are now transitioning to electric arc furnace. This makes sense given the huge difference in emissions between one method and the other, but this tendency also leads to an increasing shortage in scrap, as there is now a higher demand and the supply remains the same. Besides, this shortage is higher in cleaner scraps, leaving us with those with higher residual elements such as copper, which is negative for the steel properties and very difficult to remove. This is why it is now necessary to be as efficient as possible when managing our scraps for the melting process. In this sense, we expect that the dynamic and adaptive models developed in the s-X-AIPI will help us improve the ones that we already have. The developments in this project, such as self-abilities, autonomous manager, which are being implemented in the steel use case by our colleagues from BFI and MSI, will aid in specific aspects, being one of them the dynamic calculations of copper amount for our different scraps. These developments will definitely help us adjust to this complex scenario, keep on producing higher quality steel, and continue on the path towards reducing our CO2 emissions.
With over 50 years of experience, BFI is a leading private research institute that carrying out applied research for the process industry focusing on the steel sector. The BFI uses its know-how and extensive experience to translate the latest finding into practical and innovative solutions for current and future challenges. As a part of the s-X-AIPI project, BFI is playing a key role in the development of AI solution for the Sidenor steel use case, which focuses on improving sustainability and decarbonization in scrap-based steel production in the electric arc furnace. Our AI-driven scrap mix optimizer determines the ideal scrap mix to increase efficiency, minimize cost, and reduce carbon emissions while supporting the production of high-quality steel through this traditional recycling method.
MSI is a specialized automation engineering company based in the north of Spain. We are part of Mondragon Corporation Engineering and Services Division. Mondragon Sistemas focuses on the automation, digitalization, and optimization of production processes. And by combining these services, our main goals are to improve energy efficiency, boost productivity, enhance quality, and reduce costs. At s-X-AIPI, we work on the steel use case, focusing on the data management processes such as data collection, data processing, and storaging. We work on the integration of the AI algorithms. We work on the integration and communication with the autonomic manager, and we develop and deploy dashboard and DSS system for process control and monitoring. And this way, we enable the human-in-the-loop interaction.
The first concern regarding s-X abilities will be focused on detecting unusual situations, which is called anomaly detection, and identify the root cause of these unusual situations. Moreover, the s-X ability will rely on a repairing mechanism focused on updating and tracking the scrap properties as most critical input variable for the developed modeling tools.
What we have achieved until today in the steel use case is to close the whole data flow. We collect the raw data from Sidenor, we upload it to our server and pass it to BFI's AI algorithms. These algorithms give us some output data that we upload to the autonomic manager to be processed by it, and the autonomic manager gives us some alerts. Alerting us that something is not working properly in the production process. We show these alerts for human-in-the-loop interaction, and we pass these alerts to the scrap mix optimizer in order to give us another possibility of the scrap mix. And finally, we show all these results in several dashboards, and we show some KPIs too.
s-X-AI detection identifies anomalies by detecting deviations between the measured and predicted steel chemistry. For this purpose, a machine learning model developed by the BFI based on a random forest register is utilized to predict the chemical analysis of the steel in the furnace. The operator can view the results of the prediction models and the measurements of the chemical analysis of the steel in the furnace via the s-X-AIPI dashboard created by MSI.
Sidenor receives more than 4,000 tons of scrap every day, which makes it very difficult to address the real variation that might exist among the same types but different batches. As said before, it has always been difficult to characterize the different types of scrap and evaluate the impacts in the electric arc furnace.
For s-X-AI diagnosis, upon detecting an anomaly, the system initiates a diagnosis by applying a scrap characterization process. This involves analyzing the properties and composition of the scrap material used in the steelmaking process. A data scientist evaluates the significance of deviation in the scrap analysis, identifying the root cause of the detected anomaly. This diagnosis provides a clear understanding of how variation in scrap properties have affected the steel chemistry. s-X-AI repair follows the diagnosis. The system triggers the necessary corrective actions. The corresponding event handler adjusts the scrap property parameters and modifies the scrap mix optimizer to correct the detected issue. Additionally, the system initiates a retraining process for the AI prediction model. This continuous improvement loop ensures that the model becomes increasingly adept at predicting anomalies and preventing future deviations, thereby enhancing the overall reliability and efficiency of the steel production process.
A critical aspect for the steel use case is the recipe for its steel quality. The recipe replies to the question of which scrap type and how much of each type should be loaded into the furnace to achieve the desired quality. For this task, BFI has developed the scrap mix optimization application. Before s-X-AIPI and scrap mix optimization, the recipe selection was based on human expertise. In contrast, scrap mix optimization builds upon an optimization model to optimize the costs and enable efficient scrap reuse. To enable optimization, scrap mix optimization requires a chemical analysis for each scrap type. This analysis is based on an estimation by solving a multilinear regression model. Together, these advanced AI-driven processes pave the way towards resilient and sustainable steel production.